Question number 26. The correct reagent for the given reaction is alpha beta unsaturated 6-membered ketone transformed into alpha beta epoxy 6-membered ketone. Here the observations are the retention of carbonyl group, alkene to epoxy transformation is happened, no stereochemistry is mentioned, no ring contraction or expansion. Coming to the choices, H2O2 NaOH is oxidant in base. Dimethyl dioxazine is an oxidant. Dibol H is an reductant for carbonyl. MCBPA is an oxidant. SO3 pyridine dimethyl sulfoxide is an oxidant for alcohols to carbonyls. Coming in details, Dibol H, diisobutyl aluminum hydride, is exists in empirical formula like this, and it is an reducing agent. Exists as dimer or trimer, and it contains the tetrahedral aluminum centers with hydride ligands. The reactions are categorized into two types. One is at low temperature and another is at high temperature. So carboxylic acid will be reduced into corresponding aldehyde at minus 78 degrees centigrade, but at higher temperature it produces the primary alcohol. Same as ester also will reduce into corresponding aldehyde, but at room temperature produce the primary alcohol as reduced product. Amide will produce the aldehyde at minus 78 degrees centigrade, but produce the primary amine at 0 degrees centigrade. And nitrile produce the dibol H at minus 78 degrees centigrade with acidic workup and produce the primary amine at higher temperature like 110 degrees centigrade. Dibol H can reduce the aldehyde and ketones also. Ketone at 60 degrees centigrade converted into secondary alcohol. Alpha beta unsaturated aldehyde or aldehydes can be converted into corresponding primary alcohols without disturbing the alpha beta unsaturation. Coming to the selectivity, in presence of ester, amide can be reduced with one equivalent of dibol H at minus 78 degrees centigrade to produce the corresponding aldehyde. In the present situation, dibol H will reduce the ketone to corresponding secondary alcohol. Then MCBPA will produce the epoxy compound, which is not suitable for our answer. Poric during oxidation. The condition is SO3 pyridine in dimethyl sulfoxide is a mild oxidizing conditions. Primary alcohols can be oxidized into aldehydes. Secondary alcohols can be converted into ketones, but tertiary alcohols there is no reaction in this reaction conditions. DMDO, 3,3-dimethoxy dioxazine. It can transform the alkenes to corresponding epoxy compounds. In the present case, alpha beta unsaturated ketone will be reacted with the DMDO and forms the spiro transition state, which is concerted mechanism, which leads the epoxy compound by leaving the acetone as the byproduct. H2O2 NaOH is an oxidant in base. It also forms the corresponding epoxy compound, but without base there is no reaction. Coming to the mechanism, initially base will abstract the proton from H2O2 and leads the corresponding peroxyanion. Later peroxyanion will attack nucleophilically attack on the beta position of the alpha beta unsaturated ketone and forms the corresponding epoxy intermediate, which on resonance stabilization gives the corresponding alpha beta epoxy ketone by leaving the OH minus. Now coming to the question, here H2O2 and NaOH and dimethyl dioxazine both can produce the corresponding product. So the answer is A and B. The corresponding NPTEL reference for this question is Introductory Organic Chemistry by Dr. Neeraja Deshaputri, Department of Chemistry, IISER Pune. It comes under the addition of reactions to alkenes. Thank you.